This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Please warmly welcome Grzegorz.
So, it's good to be back. So, you might be wondering, why are we here speaking about Golang? And Golang is apparently one of those languages that are proud of being simplistic, like not having much to offer. But it turns out that even such simple languages like Golang, they have something interesting that can teach you. If I go back and think about my whole career, my whole evolution as an engineer, I think one of the most important things that I could have done for myself was to actually go and see how things are done in various different subcultures of programmers. Because let's be honest, the subculture of Java developers is different than a subculture of JavaScript developers. Or even within JVM itself, the culture of Java developers is different from the culture of Scala developers, and so on. So it turns out that even from Golang, we can learn something very, very useful. My name is Grzegorz. I'm an independent consultant. I'm mostly available for hire. I specialize kind of in fixing distributed systems, microservices, async stuff, Perl, and so on. I'm Java user group leader and Oracle ACE. But we have 30 minutes. Let's go straight to the point. So, words like imperative, boilerplate heavy, clunky, bloated, and those are the words that people use to describe Java. And Java people nowadays, they get very defensive on social media. Oh, wow, someone called my Java bloated. Actually, it's not bloated. It's actually very fast. You know, it's not Java 8 anymore. But if you go over to the group of Golang developers, they are like, the language is even more imperative, even more boilerplate heavy. And the Golang people are like, well, and so what? Yeah, it's fine. That's how we do it. Nothing wrong with that. And that's because Golang philosophy is actually pretty unique. Because if you look at modern languages, they kind of try to offer you, well, advanced syntax, a lot of advanced features. They might overwhelm you with, well, too many new things. But Golang decided to take a step back and focus on minimalism, simplicity, explicitness, productivity, and pragmatism instead. So some people do joke that any advanced syntactic features from modern languages can be approximated with finite number of for loops and if statements in Golang. And that's kind of true. So if you look at some like random example of Golang code, and by the way, I'm not expecting you to understand the code, just to get the overall feel of how it feels like. You can see, well, this is a simple algorithmic code which has quite a lot of for loops and if statements. If you try to implement a parallel web crawler, again, the code looks more or less the same, for loops and if statements all over the place. If you try to write a HTTP controller, again, for loops and if statements everywhere. The way Golang approaches things is that it focuses on simplicity. And the degree of simplicity is really extreme because there are just 3 basic data structures, 1 loop type. The language doesn't allow you to do any mocking. There's no advanced syntax, no magical frameworks, no ORMs. Well, there are some Java people that move over from Java to Golang. The first things they see is like, well, where's my Mockito? Let's do Go Mockito or like Go Hibernate or something similar. Anyway, so what can we learn from language that has nothing to offer? Just for loops and if statements. But before we go there, we need to let's focus on solving one really hard problem which people spend a lot of time on. What do you think is better, tabs or spaces when it comes to code formatting? Who thinks tabs are better? Okay, who thinks spaces are better? Okay, a lot of space enthusiasts here. So this presentation is supposed to last 30 minutes, and we've wasted around a minute discussing which is better. Is it better to use spaces or tabs? So the way Golang tackles that is that it provides a tool called GoFMT. GoFMT is a tool used for formatting code. And GoFMT uses tabs for indentation and blanks for alignment. So most of you might not like it, but you are going to format your code in Golang using this tool and using tabs. And personally, I also prefer spaces. But the way that what you can see in Golang is it will focus on being pragmatic and getting the most output out of you. And as you all might know, the problem is that you might spend quite a lot of time discussing which is more superior. Should we use spaces? Should we use tabs? Should we use should braces be optional, and so on? Golang kind of tries to kill it off. There's no room for discussion for that. That's how we do it. You would rather format your code using spaces in Golang? Sorry, we are rolling forward with tabs. Okay, let's ship something. So again, you might agree what code style is better, and I would agree that some of those are better and some of those should be considered mental illnesses. But again, no place for that in Golang. So if you ever try to discuss, okay, should we use Maven on the Gradle? Oh, sorry, the tool you are going to use in Golang is the official one. Spaces or tabs? Okay, GoFMT formats your code. And it just doesn't just do indentation, it formats everything. It's like, you stop worrying about formatting because before pushing your code, you will go GoFMT and, well, that's your formatted code. Again, optional parentheses or stuff, whatever, GoFMT will enforce or GoVet will enforce that for you. Should we follow semantic versioning or not for packages we publish? Again, Golang will force you to do semantic versioning. Which static analysis tool should we use? Well, the official one, obviously. Well, next. And so on, and so on. And this is really refreshing because I've seen projects that spent numerous hours on discussing things that don't matter that much after all. Obviously, there is some value. There's some fractional value in choosing the optimal code formatting style. But at the end of the day, the value is fractional. So for example, if you'd like to kind of try that in Java, there is a nice tool for that. You can use Spotless, which works as a Gradle or Maven plugin. You pick which format to use, and it will enforce it for you. So no more discussions under pull requests. This tool can validate the formatting and format it according to rules you define. However, in Java, it has one huge downside. It's configurable. So before you introduce it into a project, well, you can now start arguing which code style to use. Google Java format, Eclipse JDT, Palantirs. Well, we will probably spend some time discussing those first, unfortunately. But what's pretty cool is that this deep focus on pragmatism is visible in other areas as well. I believe we all agree that such thing as code formatting is superficial, but this pragmatism is visible even deep down, close to the metal. So actually, there was a talk about concurrency and about Java memory model. Let's actually revisit it here. Well, probably I won't need to explain this example to you now. So we have a simple case. We have a new thread that's spinning in a loop. And it's spinning until you hit this stop, which is set from the main thread. And the problem is that on your computer, it will probably run correctly most of the time. However, there is no guarantee that this will happen, because in order to be able to reason whether this code is valid or not, you probably all know that you need to consult the Java memory model. So the responsible thing to do is to take the Java memory model, read it, come back to this code 3 months later, after you've done your PhD from Java memory model, and then arrive at the conclusion that we just need a single volatile keyword because in the context of multi-threading, this was the one that provides the guarantees you need to make sure that this code will ever stop. So let's do the same in Golang. We have a simple case. We have an array with 2 integers, and we want to write those from 2 separate threads, or coroutines, which is more like a virtual thread in Java terms. And now we busy spin and wait until we observe the array with 1 and 2. Is the main thread guaranteed to exit? Well, we don't really know. We need to consult the Golang memory model, which is, by the way, modeled and inspired by what you can find in Java. So there are not that many surprises in there. So let's start reading it. First sentence. Programs that modify data being simultaneously accessed by multiple coroutines must serialize such access. Well, that sounds reasonable. To serialize access, protect the data with channel operations or other synchronization primitives, such as those in the async or sync atomic packages. Well, it makes sense. Let's keep reading. Here comes the third sentence. If you must read the rest of this document to understand the behavior of your program, you are being too clever. Don't be clever. And that's the whole point. Yes, we can keep reading the Golang memory model and figure out whether this is safe or not. And by the way, this is not. But what's the pragmatic thing to do? Get a PhD from Golang memory model? Well, that would make sense if you are probably working on something very low level, where actually you need total understanding of low-level semantics. But in a such simple case like this, where you want to just wait for results of produced by 2 threads to arrive, in this case, the answer is to serialize access, protect the data with channel operations or other synchronization primitives, such as those in the sync or sync atomic packages. So instead of digging down and understanding Golang memory model, Golang will push you and tell you, just forget about that, just use a dedicated tool. So for example, keep those data in atomic integers. Okay, move on, go on, solve another problem. And this is very much refreshing because in the Java world, I've seen so many discussions about memory model, whether which barrier to use, whether in most cases the answer was just don't worry about this, use volatile or synchronize. Because we were trying to over-optimize things that were not important at that point in time. The solution was much easier, much more higher level. Another cool thing that Golang does is it forces you to do dependency inversion. And this is a thing that causes a lot of trouble for people, especially in the Java world, because Golang's interfaces, they are used for something totally different than interfaces in Java. In Java, interfaces, abstract classes, sealed interfaces, or so on, those are the main building blocks that allow us to shape our domain. So we model our world in the code, we create abstract classes, we create this hierarchy of types to represent something. However, Golang technically is not an object-oriented programming language. It's a structural language, but it still decided to include interfaces. But they are used not by a producer of something, but consumers use it, which is very counterintuitive. But let's see an example. So we have a movie rental service, which is a structure, think object. In order to be able to rent a movie, it needs to it has 3 dependencies. It needs to be able to save or rent or return a movie, which would be done via rental repository. It needs to be able to find movie details, which can be fetched from movie descriptions repository. And it needs to be able to check whether a movie exists. And this is done through movie repository. And the way you would do that in Golang is that you would make those dependencies interfaces. So movie rental service would define explicitly what functionality it needs from its dependencies. So we know that rental repository is effectively two methods. Movie description repository is just one method, and movie repository is one method as well. So as you can see, this whole class, the whole struct, I mean, they are called structs in Golang. It depends on three interfaces, behaviors, but not on concrete types. And the way you would normally, and the way it works is that in Golang, you don't need to implement interfaces. So when you create a new class, you don't need to say implements this, this, and that. Interfaces are implicitly implemented. So if you pass any object that has similar methods directly to movie rental service, Golang will gladly accept that. It's just the signatures of methods need to match. So now, let's move on. So our movie repository needs to be able to give us a movie. Well, let's implement that on VUC by, let's fetch those from Postgres. Let's make a simple query, ignore the boilerplate. Well, and we are fetching this data from Postgres. Done. And now another one. Now let's deal with our rentals. We need to be able to rent and return movies. Okay, two simple inserts, and here's our repository. Done. Let's fetch movie details now. Oh, but that's not Postgres anymore. That's a REST data source. So we have REST movie descriptions repository, which has this method and actually calls some external service to fetch some movie metadata or like description, IMDb-like descriptions. So you might be thinking like, okay, the movie descriptions repository was actually supposed to be from a database, but the slow coupling I achieved by introducing interfaces in consumer level that actually allow you to inject anything you want there, as long as it complies with the method signature. So now, when we want to compose to create a new movie rental service instance, we just pass those new instances directly into it. And as you can see, Postgres rental repository doesn't implement any interface. This is all done implicitly because we have methods that match the structure. And so we achieve not only dependency inversion, but also dependency injection, because guess what now? You don't need a special magical container where you have some floating bins which get connected together, wired up, and returned as complete objects. The core idea of dependency injection is simply taking objects and supplying them externally into other objects. So instead of constructing them locally inside an object, you just supply them externally. So that's effectively what's happening here. Rental repository, descriptions repository, movie repository, we supply them externally to movie rental service. And that's all. However, now there are problems. Okay, there's dependency injection, which was easy to do because Golang forced us to use interfaces on consumer side. Okay, but why would they do that? Because now it's time to test it. But how do we test it? We don't have mocks. We don't have Mockito and stuff. But guess what? The whole act of defining interfaces and on the consumer side allow you to inject anything you want in there. So what you could do instead, for example, create fakes, like fake in-memory rental repository or stubbed movie description and so on. You inject those to a class, and now you can test it black box style, because you have a movie rental service where you can rent, return a movie, check description, and so on. And this is going to work on, for example, fake implementation. And this is going to be much better than your mocks, because mocks usually allow you to test a very slice of implementation, not the whole thing. But in this case, you can test the whole thing going through the whole flow. You can add something inside and take it out and verify whether this thing works. You can't do this with mocks. Obviously, this is the real test that you would do. It's at integration level. But if you want to do something fast, this is going to give you much more value than going for mocks. And when I say mocks, I mean not stubs, because the problem with Mockito is that most people use Mockito for implementing stubs. This is fine. But the problem is that if you use those stubs and you try assert that some activity was done, this is when a stub becomes a mock. And this is problematic because you kind of wire yourself into implementation details instead of asserting on observable results of some actions done by some component. And guess what? We can do the same thing in Java. So we have movie rental service in Java. We can create interfaces. I put them in the same class for convenience, but they don't need to be there. And now, if you've done the same, now let's prepare in-memory rental history repository, which is actually internally just a list of movie rented events. And nowadays, especially with Copilot and AI tools, this is so easy to roll out. It's like it's one big autocomplete that will give it to you working pretty much for free. And now we can construct a test. So let's say we rent a movie and then we check if the movie was actually rented, which is quite a trivial case, but it allows us to test the whole flow. We've rented a movie and then it's in the list of rented movies by a certain customer. And we do it all with in-memory data structures, like in-memory fakes. And with the common presence of Hibernate and so on, we also arrived at the conclusion that we need to do something better. And that's how, like those 20 years ago, 15 years ago, all those in-memory replacements for databases were born. They wanted to allow you to test things as fast as possible without spinning the real database. That's where the H2 or Apache Derby got popular. But if you have this trick with interfaces, you don't need to do that because, well, you can be running on an array list effectively. And those tests have one huge advantage. They are super fast. So, for example, this is a single test, but let's run it 10,000 times. On my computer, I don't know if you can see that, but this is running absurdly fast. So I can run the same test 10,000 times in less than 50 milliseconds. That's a lot. And in IntelliJ IDEA, there is this really nice trick that you can use. There is this special button. It's called Rerun Automatically. And if your tests are really fast, that works really well. What does it do? It effectively allows you to make sure that tests are rerun after every time IDEA flushes the updates to disk and recompiles project. If it sees any differences, any changes, it will run all the tests, which gives you near compile time feedback. So that's actually the thing. The functional programmers consider the holy grail of functional programming is the fact that if your program builds and compiles, it should work, which is an utopia and very hard to achieve. So, for example, not that long time ago, we had quite a popular case being posted on Twitter. Scala developers were so excited that someone managed to incorporate Sudoku rules at type level. So the way it would work is that if your Sudoku is not properly solved, the project would not compile, which is, well, exciting and quite interesting. But if you actually looked at the code behind that, like the type rules that you needed to inbuilt into the type system in Scala, that wasn't so nice. However, using this approach in Java is super easy. It works with any domain. So I've done the same with Sudoku, and, well, technically, it's not compile time validation. It's near compile time, but it's also good enough because you still get feedback after a couple of seconds of making a mistake. But the best thing is this can be easily translated to any domain you want. So let's go back to our case with renting movies. I'm not sure, is it running? Yes, it's running. So let's say I have all my tests running purely in memory. Well, not all, let's say the unit ones. I have this rerun automatically turned on. So I go around my code, I change things, and I make an accident. By accident, I remove a critical code line. Just like you can see here. It takes me just a couple of seconds to all my 10,000 tests fail or pass if I manage to correct an example. So this is one of those super tricks I really like, because now when I'm moving around my code, if I make a dumb mistake, I get feedback instantly. I don't need to wait to run tests that runs for minutes or so. And by the way, this concept is well known. Well, the diagram is overcomplicated, but this is essentially hexagon architecture. And Golang is forcing you to do it, because it's the only way you can effectively test it. Well, Java developers are trying to come up with like automatically code-generated mocks from interfaces and so on. But in Golang, it kind of forces you to do it. So that's another cool thing. Well, that you can, in Golang, you are forced to do that, but it's still something that works really well in Java. Another thing which is pretty cool in Golang is that it forces your, well, that's not something you can really do. You don't benefit that much in Java world, but Golang forces your programs to be acyclic. What does it mean? Imagine that you have one package, main, and that package imports a user. So we have a package that's supposed to allow you to register some users. Okay. And it has a type user, it has a method register, and notify user. So now let's look at package email. It has only send welcome email and send, but it has accepts a user component over in here. So it imports a user. And now you have a problem, because your user package is trying to register, allows you to register a user and also notify, send an email to that user. But in order to build, that email package also needs to have this user struct available to be able to resolve the body and, let's say, email address properly. And Golang doesn't allow you to do that. And cycles are, well, in Java, it's not that big of an issue, but for example, if you try thinking as someone who's building build tools, that's a big problem, because whenever you try to recompile your project, you need to recompile the whole cycle. And projects usually, once you have cycles inside, it all turns into one huge cyclical blob. Golang, thanks to this, can be blazingly fast. So the native binary it produces, usually just hundreds of milliseconds, because it doesn't really need to rebuild the whole thing. It rebuilds one of the leaves or subtrees in the AST. This is super fast, but nice side effect of that is that it forces you to think in modules and structures instead of making one huge mess of your code base. And a very easy solution here, as acyclic design would be, is for the email package to have the send function, but not accept the whole user struct, but just body and email strings, right? So as you can see, it's not that hard after all, but it's way easier to maintain projects that have some separation of concerns, or thus modularized in some way, where modules means independent units that have some, that form a graph, instead of just being a directories where you put your class files. And so from time to time, people come over to the Golang's GitHub and complain and say, yes, we know that acyclic design is nice, but please undo it. Please allow us to skip that. But the original founder and the Golang designer reminds people that it will be there forever. Anyway, something that's super easy to implement in the Java world, which also doesn't give that big benefits as in Golang, but still worth trying because it's super cheap to implement, is to use ArcUnit. So ArcUnit is a tool that allows you to pretty much build assertions for your architecture. And well, this is a really simple one that you can use that forces your code base to be acyclic and is able to spot that. So that's pretty cool. And the last thing I have for you for today is something that you actually won't be able to use in Java. Well, you could really try, but this is again fighting with the language itself. But Golang has really nice approach to exceptions and errors because, well, errors and exceptions are technically not the same. And the approach to errors in Golang is that errors are values. There's nothing special about them. Those are not special objects that traverse stack traces and that can be caught somewhere in a different part of the program. That's just a value that's returned by a function. There's literally nothing special about that. Because again, think, if you are dividing, let's say, an integer by 0, well, that is undefined, right? But is it really an exceptional situation? Well, that's the outcome of that situation is perfectly predictable. You are not allowed to do that. You shouldn't do that. But shouldn't you launch a magical object that's going to crash your thread when uncaught? Probably not. Golang differentiates between, like predictable errors and unpredictable errors. And an unpredictable error would be something like you try to, let's say, add two integers, but actually the runtime totally crashes and there's nothing you can do about that. And that's where it reserves a special keyword, panic. And panic mode, when panic mode happens, it means something went really, really wrong and you should probably stop the program at all. But for normal errors, those are simple values. And the cool part about Golang is that you can return multiple values from a function. So if you have a function foo that accepts a string s, it might return a string and an error in this case. And here comes the ugly part. So the way it's done in Golang is that you are just supposed to check whether an error is not null. And this is disgusting. However, it has a nice quality because the predictability of getting a value and being able to check whether it's an error or not, it's quite convenient, it's quite predictable, it's nice. However, the implementation in Golang with error not equals to null is absolutely disgusting. And people usually make a lot of fun about the Golang that, well, let's be honest, because the whole Golang code bases are quite often polluted with those error not equals null. But it has but the whole concept has a nice quality to it. If you really wanted to kind of port that to Java, you could use records to kind of model multiple return types inside one function. It can work. I wouldn't advise you to do that, but I've seen some people playing with that. You could use an either for waiver, which is not the same as the thing in Golang. It moves some concerns of error handling into the type system because, well, again, you can return either one type or another from a function. But again, it's not like trying to copy what Golang does. So this is good to know, good to be aware of, but personally, I wouldn't stress too much about making sure that trying to use Java this way, because, well, Java was never designed to be used this way. So at the very end, I'd like to remind you that what I'm trying to do is I'm trying to broaden your horizons. I'm not saying just take all of that and blindly copy into your projects. Common sense is always the ultimate best practice. I'm trying to show you the qualities and, well, pros and cons of those approaches, but only you know your context and you should assess ultimately if this is something that would help you in your project. So thank you very much. That's where you can find the slides. You can find me on socials, ask questions after the talk, whatever. Thank you.
Who want to ask question?
I'll be still around here for a minute or so.
Thank you for the presentation. In what situation would you prefer to select Golang instead of Java to develop an application?
Okay, that's a really good question. So the question was about when to prefer Golang over Java. So first things first, as you noticed, the language with a primitive syntax, it has some advantages. But again, if your project that you're trying to work with every day, it has a very feature-rich and rich domain in general, you would probably benefit more from using a language that is more expressive than Golang, which just gives you for loops and if statements and nothing more. Well, a bit more. However, if there's no domain and the project you are doing is a database proxy, a sidecar container or something like that, that's effectively where you would default to like lower level language. And that's, for example, where Golang shines a lot. So I worked for a startup for a brief moment that was actually building a database proxy. And well, there was no domain there. It's like the domain you're working with is abstract syntax tree, leaves, and so on. You just juggle strings, primitive values around connections, result sets, and so on. There's no domain there. However, I could produce native binary. I could build it in last 200 milliseconds. And I could package this native binary into a Docker container. It would take less than a second. And I could rerun the whole process in less than a second. Make a change, rerun it, less than a second, you have native binary in the Docker container running. Image would have like 20 megs. Web server, racks, being able to accept HTTP requests and sending stuff over to a database. Less than 20 megabytes of an image. You can do it in Java with GraalVM, for example, but if you try that, you'll see that producing a static binary, even from a Hello World project, takes a couple of minutes. And in Golang, you can do it with them. So answering your question directly, infrastructure projects mostly. Docker is built on Golang. Kubernetes is built on Golang. Kong's API gateway is built on Golang, and so on. It shines really there. But I quite often see it mixed with Java. So like core domain services will be written in Java, but for example, service responsible for authentication or sending emails, something that would be in Golang. Or lambdas that you use that accompany your normal services that could be run in Golang as well.
Thank you so much. And now it's a time for our community award. Please welcome Paweł.
Dziękuję.